In the dry heat of central Sudan, along a bend in the White Nile, a team of archaeologists brushed sand away from a row of skulls that had been buried for 9,000 years. The site was called Al Khiday, an unremarkable patch of land that did not look like much from the road, just pale earth and scattered stone, the kind of place a traveler would pass without a second glance. But beneath that surface lay something that would quietly upend a long-standing assumption about ancient human health. The skulls being uncovered, some belonging to hunter-gatherers from the pre-agricultural era, others to farming people who came thousands of years later, shared a feature so consistent and so strange that the researchers had to stop and recheck their numbers. Almost none of these people had cavities. Less than 1% of the teeth they examined showed any sign of dental decay, abscesses, or the kind of erosion modern dentists see in patients every single day. This was not a small sample. It was hundreds of teeth across multiple time periods, including a population that had clearly transitioned to eating grain, the very food group that should, according to every textbook on the history of dentistry, have flooded their mouths with fermentable sugars and rotted them out from the inside. Yet the teeth were intact, the enamel was clean, and clinging to those teeth, hardened over millennia into a stony layer of calcified plaque, was the chemical fingerprint of a single, specific plant. That plant was Cyperus rotundus, known in English as purple nutsedge, in the fields of farmers as nutgrass, in tropical agriculture as cocoa grass, and in the ancient Sanskrit traditions of India as mustaka. It is, by global consensus among weed scientists, the most invasive plant on Earth. It grows on every continent except Antarctica. It has been documented in more than 90 countries. It thrives in lawns and ditches and the hairline cracks of city sidewalks. And it does this with such relentless determination that an entire branch of agricultural science exists primarily to figure out how to kill it. Farmers around the world spend, collectively, billions of dollars every year trying to eradicate this weed from fields where it can reduce crop yields by 20, 50, even 90%. It is hated, it is poisoned, it is dug up, burned, sprayed, plowed under, and yet it returns, again and again, from a network of underground tubers so deep and so resilient that the plant has, in agricultural literature, been described as essentially impossible to eliminate once it has established itself in a field. And the discovery at Al Khiday, published in the journal PLOS ONE in 2014 by Buckley, Usai, Jacob, Radini, and Hardy, suggested something almost absurd. The same weed that modern civilization spends a fortune trying to destroy is the plant that ancient civilizations spent at least 7,000 years chewing to keep their teeth almost completely free of decay. When you do not brush your teeth, the bacteria in your mouth form a soft film called plaque. Over time, that plaque hardens, mineralizes, and turns into a stony deposit that fuses to your enamel. Modern dentists scrape this off during cleanings. But for archaeologists, that hardened plaque is a treasure because every meal a person ever ate, every herb they ever chewed, every smoke they ever inhaled, leaves microscopic traces locked inside that mineral matrix. It is, in effect, a biological time capsule sealed against the open mouths of the long dead. When researchers at Al Khiday examined this calcified plaque with chemical analysis, they did not find random plant matter. They found repeated, distinctive biomarkers, the same compounds, across hundreds of teeth, across thousands of years, from hunter-gatherers and from farmers, from men, women, and children. The signal was overwhelming, and it pointed in one direction. These people were not casually nibbling on this plant. They were using it deliberately, consistently, generation after generation, in a way that suggested it was a normal and integral part of daily life. They were, in every meaningful sense of the term, brushing their teeth with a weed. And here is where the story turns from archaeological curiosity to something much harder to dismiss. In the years since that paper was published, laboratory studies have begun to confirm in clinical detail exactly why those ancient teeth were so clean. The primary villain of modern tooth decay is a bacterium called Streptococcus mutans. It lives in the mouth, it feeds on sugar, and it produces acid as a byproduct. That acid, more than any other single factor, is what dissolves enamel and creates cavities. If you can suppress Streptococcus mutans, or interfere with its ability to stick to your teeth, or shut down its acid production, you have, in essence, dismantled the engine of dental decay. And Cyperus rotundus does all three. In vitro studies have shown that extracts of the plant cut the ability of Streptococcus mutans to adhere to tooth enamel by more than 50% at concentrations as low as 0.5 milligram per milliliter. At 4 milligrams per milliliter, the bacteria are inhibited entirely. The plant also disrupts the acid production pathway, meaning that even where bacteria persist, they cannot do the chemical damage that erodes enamel. One published study went so far as to compare its antibacterial action to chlorhexidine, the prescription-grade antiseptic mouthwash that dentists use as a clinical benchmark, and found that the plant extract was competitive with a 0.2% chlorhexidine solution. That is not a folk remedy. That is a measurable, reproducible pharmacological effect. The activity does not stop at cavity-causing bacteria. The same plant has demonstrated antimicrobial action against Aggregatibacter actinomycetum comitans, the bacterium most strongly associated with severe gum disease, and against Candida albicans, the fungus responsible for oral thrush in immunocompromised patients and in infants. In laboratory conditions, it behaves like a broad-spectrum oral antiseptic, and if it were synthesized and patented by a pharmaceutical company tomorrow, it would be marketed as a breakthrough oral health compound. The active molecules have been identified. There is a sesquiterpene called mustacone that contributes to the antimicrobial action. There are flavonoids that inhibit the cyclooxygenase 2 enzyme, the same biological target as ibuprofen, so the plant has measurable anti-inflammatory effects on top of its antibacterial ones. A complex of essential oils accounts for its distinctive aroma and contributes to its antiseptic profile. None of this is mystical, and none of it requires a leap of faith. In the dry technical language of pharmacology, it is a multi-target botanical agent with documented activity against the precise organisms responsible for the most common diseases of the human mouth. Hold that fact in your mind. This plant is, by laboratory measurement, an effective anti-cavity, anti-gum disease, antifungal oral agent. Now consider where it grows. It grows everywhere. It grows in the median strip of the highway you drove on this morning. It grows in the unmown corner of the public park where children play. It grows on farms in India, in the Mississippi Delta, in the dry plains of southern Australia, in the volcanic soils of Hawaii, along the irrigation channels of the Nile Delta, and in the cracks of concrete in cities from Karachi to Houston. It is a perennial sedge, not a true grass, and it propagates through one of the most stubborn underground architectures in the entire plant kingdom. A single plant can establish a chain of tubers, basal bulbs, and rhizomes that snakes through the soil and reaches deep beneath the surface, where it remains protected from herbicides, from plowing, from drought, from cold, and from time itself. Tubers can lie dormant for years and then sprout again the moment conditions are favorable. You can dig up an entire field, sift the soil, burn the surface, and the plant will return because somewhere down there, beneath the depth of your shovel, a single tuber is waiting. This is not a weed that you control. This is a weed that you negotiate with, and in that negotiation you almost always lose, which is why, paradoxically, it has been one of the most reliably available medicinal plants in human history. The very traits that drive farmers to despair, its drought tolerance, its underground reserves, its capacity to spread aggressively across disturbed soil, are also the traits that ensured that whenever and wherever ancient humans needed it, it was there. It did not require cultivation. It did not need irrigation. It did not depend on a particular climate or season. You walked outside, and there it was, and there it had always been, and there it would always be. In Ayurveda, the traditional medical system of the Indian subcontinent, mustaka has been documented as one of the most prized herbs for more than 2,000 years. It appears in the classical texts under names that translate roughly to fragrant, cooling, and mind-clearing. It was prescribed for digestive complaints, for fevers, for menstrual disorders, for inflammation, for skin diseases, and for the care of the mouth and gums. In traditional Chinese medicine, the same plant, called xiang fu, has been used as a regulator of the body's energy flow and as a treatment for pain. The Egyptians used it, the Greeks used it. Arab physicians of the medieval period wrote about it. Across cultures that had no contact with one another, across continents and centuries, human beings independently arrived at the conclusion that this plant was worth using. Modern pharmacology, when it has bothered to look, has confirmed many of those traditional claims with the cold rigor of laboratory testing. Anti-inflammatory action validated in animal models, antioxidant activity measured against standard chemical benchmarks, antimicrobial effects documented against a wide range of bacteria and fungi, anti-diabetic effects in rodent studies with measurable reductions in blood glucose, analgesic properties demonstrated in pain response trials, antispasmodic effects on smooth muscle that align with its traditional use for menstrual cramps and digestive distress, and gastroprotective action against the formation of stomach ulcers. The list goes on, and the published literature, while still limited compared to that of mainstream pharmaceuticals, is substantial enough that pharmacology textbooks now include Cyperus rotundus as a botanical of significant therapeutic interest. This is not a story of pseudoscience. This is a story about a plant that has been quietly, patiently generating positive results in laboratory after laboratory, while the public conversation about oral health remains entirely focused on toothpaste tubes lined up on a supermarket shelf. So how, then, did we forget? How did a plant that ancient humans relied on for at least 7,000 years, that grows on every continent we inhabit, that has measurable, reproducible, peer-reviewed effects on the bacteria responsible for tooth decay, vanish almost entirely from the modern conversation about dental health? The answer, when you trace it carefully, is not the answer of conspiracy. It is the answer of economics, of patents, of colonial agriculture, and of a quiet but absolute shift in how human societies categorize the green things growing around them. Modern industrial dentistry was built, almost from its foundation, around three pillars. The first was fluoride, a compound discovered to harden enamel against acid attack. The second was the surfactant, the foaming agent that gives toothpaste its theatrical lather and convinces the user that something is happening. The third, and most important from a business perspective, was the patentable compound. A toothpaste formula that nobody else can legally replicate is a commercial asset. A formula based on a roadside weed that anyone can dig up for free is not. There is no shareholder value in the sidewalk. This economic reality shaped everything that came after it. Toothpaste, as we know it, became a global product through aggressive 20th century marketing campaigns that redefined oral hygiene as something that required a tube, a brand, and a recurring purchase. Colgate-Palmolive, Procter & Gamble's Crestline, Unilever's various dental brands, and a handful of regional competitors built a global oral care industry that today generates more than $30 billion in annual revenue. That scale is worth pausing on. Products that perform a function that ancient humans, by archaeological evidence, accomplished by chewing on a plant that is currently classified as the world's worst weed. Now, this is not to say that modern toothpaste does not work. Fluoride is a genuine scientific advance. Mechanical brushing matters. The combination of toothpaste and a toothbrush, used consistently, is a real public health intervention. But the existence of one effective intervention does not erase the fact that another, simpler, free intervention existed, was used for thousands of years, and was discarded not because it failed, but because it could not be sold. There is, layered on top of this, a second story, and it is the story of how colonial agriculture rewrote the categorization of the natural world. In the 19th and 20th centuries, as European agricultural systems spread to new continents through colonial expansion, A vast effort began to classify plants into useful and useless, crop and weed, friend and enemy. The criteria were entirely economic. Plants that produced harvestable yields at industrial scale were elevated, and plants that competed with those crops were demonized. Cyperus rotundus, with its aggressive growth and its competition with sugarcane, cotton, rice, and corn, was placed firmly in the enemy column. Agricultural extension services across the colonized world devoted themselves to its eradication. Farmers were taught in schools and pamphlets and demonstration plots that this plant was a pest, a thief of yield, an obstacle to progress. The traditional knowledge held by indigenous and rural communities, the knowledge that this plant was also a medicine, a tooth cleaner, a remedy, was not actively suppressed in most cases. It was simply ignored. It did not appear in the new agricultural curricula. It did not fit the new framework. And when colonial schooling replaced traditional knowledge transmission across 2 or 3 generations, the framework that survived was the one that had been written down in the new textbooks. The framework that had lived only in the spoken instructions of grandparents to grandchildren faded. That fading was not dramatic. There was no moment when the world decided to forget. There were just households where the elderly chewed the root because they had always chewed the root, and grandchildren who were sent to school and came home with toothbrushes and tubes of mint paste, and a vague sense that the old practice was somehow embarrassing, somehow unscientific, somehow backward. Within 2 generations, in many parts of the world, the chewing tradition was effectively gone. The plant was still there. It was still growing in the ditches behind the school, but nobody remembered why it mattered. The link, which had been maintained for at least 7,000 years through nothing more than the daily example of one generation to the next, was severed in less than a century. This is one of the quietest extinctions in human history, not the extinction of a species, but the extinction of a relationship. The plant survived. The knowledge of what to do with the plant did not. And there is a final layer to this, which is the structural blindness of modern medical science to plants that cannot generate funding for their study. To run a clinical trial on a pharmaceutical compound costs tens of millions of dollars. That money comes, in almost every case, from a company that expects to recover the investment through patent-protected sales. A compound extracted from a freely available weed, a compound that any person could replicate by walking outside, cannot be patented in any meaningful way. There is no economic incentive for a company to spend $10 million proving in a randomized controlled trial that nutsedge prevents cavities, because the moment the trial is published, anyone in the world can simply chew the plant. The market does not reward the discovery. And so the studies that do get done are smaller, less well-funded, often performed in regions of the world where research budgets are tighter and where the interest in traditional medicine remains stronger. They are published in journals that the average dentist in the West will never read. They accumulate in a slow, scattered way, never reaching the critical mass of attention that would force the mainstream conversation to acknowledge them. The science is real, but the megaphone that would amplify it does not exist, because the megaphone runs on advertising revenue from the very companies that benefit from the status quo. At this point, the careful viewer should pause and consider the limits of what we are actually claiming. While the archaeological evidence is striking and the laboratory evidence is compelling, the human clinical evidence is still thin. There has not yet been a large-scale, randomized, controlled trial in which a population of modern humans is randomly assigned to use Cyperus rotundus as a daily oral hygiene agent and tracked over years for cavity rates, compared to a control group using conventional toothpaste. That study, the kind that would put the question to rest, has not been done. What we have is the archaeological correlation, an extraordinarily strong one, in which populations who used the plant had almost no cavities. We have laboratory studies showing that the plant inhibits the bacteria responsible for cavities. We have ethnographic and historical evidence from multiple traditional medical systems endorsing the plant's use. We have animal studies, in vitro studies, and chemical analyses identifying active compounds. This is, by any reasonable standard, a substantial body of evidence pointing in the same direction. But it is not a clinical trial in modern humans. The honest scientific position is that the case is suggestive and warrants serious investigation, not that it is conclusively proven for the purpose of replacing your existing dental routine. There are practical cautions that any serious documentary on this subject must include, because the popularization of traditional remedies has a long history of going wrong when it strips away the context of how those remedies were originally used. Do not, on the basis of this story, walk outside and dig up the first nutsedge you find growing along the highway. The roadside soil in the modern industrial world is often contaminated with heavy metals from vehicle exhaust, with petroleum residues, with herbicide overspray from municipal weed control programs, and, in agricultural areas, with decades of accumulated pesticide. The plant may also be growing alongside look-alike species, including some that are not edible and some that are mildly toxic. Accurate identification requires knowledge that most modern people do not have. The archaeological people who used this plant lived in environments that had no industrial contamination, no synthetic pesticides, and no leaded gasoline residue. They knew their local plants with a precision that most of us have lost. To replicate their practice safely, you would need clean, identified, traceable plant material, ideally cultivated under controlled conditions, and that is not what is growing in the alley behind your apartment. So the point of this story is not to throw out your toothpaste tomorrow. The point is much larger and much more uncomfortable than that. The point is that we, as a civilization, have been so committed to a particular framework of value, the framework that says nature is either crop or weed, asset or liability, profitable or worthless, that we have repeatedly walked past extraordinary biological resources without noticing them. The point is that the same plant that humans across multiple continents independently identified as a tooth cleaning agent, the same plant whose role in dental health is now confirmed by laboratory science, has been treated for the last 100 years as something to be poisoned out of existence. The point is that there is a gap between what we know and what we use, and that gap is shaped not by truth, but by economics. The point is that when you walk past a sidewalk crack and see a tuft of green pushing through the concrete, you might be looking at something that, in a different version of human history, would be sitting in a tube on the shelf above your bathroom sink. The point is that the things hiding in plain sight are sometimes the most important things, and the reason they are hidden is rarely that they are hard to find. It is usually that we have been taught not to see them. The Khiday skeletons did not give a speech. They did not write a manifesto. They simply lay in the Sudanese soil for thousands of years with their teeth intact, holding a chemical record in their mouths that contradicts almost everything our culture believes about the inevitability of dental decay. They are, in a sense, the most credible witnesses we have because they have nothing to sell, no agenda, no shareholder, no quarterly earnings report. They were people who lived, ate, raised children, and died, and whose bodies preserved a fact that we are only now beginning to understand. The fact is that cavities, the plague of modern teeth, the multi-billion-dollar problem that fuels an entire industry of dentistry and oral care, were not inevitable. They were not a natural consequence of being human. They were, in significant part, a consequence of forgetting. And the thing we forgot was a plant that has never gone anywhere. We spent 9,000 years chewing it. We spent 100 years killing it. The cure for cavities, or at the very least a meaningful contributor to oral health that our ancestors used and benefited from, may have been growing through the cracks in your sidewalk this entire time. It is still growing there. It is, in all likelihood, growing within walking distance of wherever you are watching this. And the question that hangs over the whole story, the question that should make any thoughtful person uncomfortable, is, what else? What else has been growing in plain sight, dismissed as a weed, ignored by a medical industry that cannot profit from it, demonized by an agricultural industry that competes with it, while quietly carrying within it the kind of biological activity that ancient humans understood and that modern laboratory science is only now rediscovering? How many other purple nutsedges are out there, treated as enemies of progress, while in fact being something much closer to forgotten allies? Because if it happened with this plant, with this thoroughly documented, archaeologically confirmed, pharmacologically validated plant, it has almost certainly happened with others. The pattern is not about Cyperus rotundus specifically. The pattern is about the way our civilization sees the natural world. Maybe it is time to remember why our ancestors valued what we now poison. Not because their entire worldview was correct, and not because every traditional remedy will hold up under modern scrutiny, because many will not. But because the assumption that the past was ignorant and the present is enlightened is itself a kind of ignorance. And because 7,000 years of consistent practice across multiple unrelated cultures is data that deserves, at minimum, a respectful hearing rather than the silent dismissal it has received. The skeletons at Khiday spoke a language of preserved enamel and calcified plaque, and in that language they said that there was once a way of caring for the human mouth that worked, that was free, that grew everywhere, and that we have, almost completely, forgotten. The science is now beginning to catch up to what those people knew. The remaining question is whether we will catch up to the science, or whether the economics of a $30 billion industry and the inertia of 100 years of weed eradication will continue to drown out a plant that has been waiting patiently in the ditches and the field margins and the sidewalk cracks for someone to finally notice it again. The plant is not going anywhere. It cannot be killed. It will outlast every herbicide and every patent. The only question is whether we will keep walking past it, or whether one of these days we will stop, kneel down, and look at it with the eyes of the people who knew exactly what it was.